So this is a fun section. I don't know why I like this one so much, but this is a topic called completing the square. And the goal of this here is to create what's called a perfect square trinomial. So you're probably saying, well, what is a perfect square trinomial? Well, why don't we take a minute and define what a perfect square trinomial actually is? I think that might be helpful to do. So a perfect square trinomial is when you express a trinomial there we go, as what we call a squared binomial. So think about the vocabulary there for a minute. We're taking a three-termed expression, a trinomial, and we're going to write it as a two-termed expression squared. A lot easier to show you than just explain it to you. So what I mean by that is I'm going to take this first one, x squared plus 6x plus 9. I'm going to factor it. So I'm going to think about the factors of 9, things that multiply to 9 and combine to 6. So you're probably saying by this point it's going to be a 3 and a 3. We've got to go back to our factoring for this a little bit. So when I factor this, it's going to factor to x plus 3 times x plus 3. And here's what makes it what makes this x squared plus 6x plus 9 a perfect square trinomial, is that when we write the answer, we can write it as the square of x plus 3. So that's a squared binomial. A squared binomial is something like the square of x plus 3. So that means that the trinomial x squared plus 6x plus 9 is a perfect square trinomial. Let's do the next one as well. So again, now we're looking for numbers that multiply to 1 and combine to a negative 2. So if we do our factoring, it's going to be x minus 1 times x minus 1. And again, if we're going to rewrite it as a squared binomial, we're going to write it as x minus 1, that quantity squared, so the square of x minus 1. So that process that we're going to do, though, to create these perfect square trinomials is called completing the square. So what I'm going to do is I'm going to create a perfect square trinomial that's going to use the expression x squared plus 4x. So what I really mean by that is I'm going to have x squared plus 4x, and let's see, we'll use green. I want to put a number in that box so that when I factor this, it factors eventually to something squared. And here's how I'm going to get that number that goes in the box. The number that goes in the box, here's what I'm going to do, is I'm going to take the 4 that's in the middle, I'm going to divide it by 2, and then I'm going to square it. For extra bonus points, ask me tomorrow why that number is found by the process called completing the square. What square are we completing? I'll show you that tomorrow. So if I figure this out, 4 divided by 2 is 2. 2 squared is 4. So my box, that value is equal to 4. So I'm going to put a plus 4 in here. Now when I factor it, it's going to factor to x plus 2 times x plus 2. And notice, how did you get the 2 though? Well, the 2 is because it's the square root of my box number. So whatever number's in the box, I take its square root, and I get 2. So then we're going to rewrite this then as the square of x plus 2. So let's generalize it a little bit. So the rule that we want to kind of follow, and we'll do this in red because it's an important rule that we want to do. If we have a polynomial called x squared plus bx, we're going to say, where the b value is just the number that's in front of the x. And did you remember that the a value is 1 here? So there's like an imaginary 1 in front of the x squared. That a value is 1. What we want to figure out is what I call the new c value, because the c value is the number that we'd add to the end, the constant. And that new c value is the square of b over 2. So we take the coefficient of x, divide it by 2, and square it. And that's what we put at the end of the equation. So let's work through one or two together. So let's make some perfect square trinomials. What I'm going to do is I'm going to fill in the number that goes in the blank space. And then I'm going to write it as a squared binomial. So I'm going to take my 8. 8 is my b value in this case. And we'll kind of work through this one and I'll turn you loose. So b equals 8. So what I'm going to do is I'm going to take my 8, divide it by 2, and square it. And that's going to give me 16. 8 divided by 2 is 4. 4 squared is 16. So I'm going to put a plus 16 there. And now when I factor this, remember, x squared goes to x times x. 16 is 4 times 4. Because the 8 is positive, I'll put a plus sign there. And I square it. So my perfect square trinomial becomes the squared binomial, the square of x plus 4. And that's how far we want to get to. So let's do the one right underneath it. Let's do this one together, and then I'll turn you loose on the other two. So what I'm going to do is I'm going to take my b value. My b value is negative 12. I'm going to divide it by 2 and square it. Negative 12 divided by 2 is negative 6. Squared is 36. So I'm going to put a positive 36 in there. And yes, that number is always positive because we're squaring it. So now when I factor this term, x squared, its square root is x. 36, its square root is 6. And I wrote a plus sign, and I did it wrong because the 12 is negative, so it should be x minus 6. So the square of x minus 6. You try the next one. Determine what the final squared binomial is. So I'm going to take my negative 18 and divide it by 2. Squared it gives me 9, which I square, and I get 81 for my number. So I'm going to put a plus 81 in there. So when we factor this now as a perfect squared binomial, we'll get x subtract 9, the square of x subtract 9. Let's do one more. Can you try this bottom right one? So I take my 10, I divide it by 2, I square it. 10 divided by 2 is 5. 5 squared is 25. There's my perfect square number. Let's write it in parentheses now. It's the square of x minus 5. So let's keep going a little bit. You see why these are a little different? Yeah, we have a 5 and a 7 and an 11 and an x or a 1 in there. These are odd numbers. So let's see what happens when you have an odd number. So the same process though. I'm going to take my b value, I'm going to divide it by 2, and I'm going to square it. But check this out now. I don't really want to leave it as a decimal. You'll see why later on, why the fraction is helpful to do. So I know you're saying, oh no, I got to square 5 over 2. But square 5, and you get 25. Square 2, you get 4. Guess what? That's the number that goes there. And I know what you're saying. You're saying, oh yeah, but I got to factor it, I know. But remember, it's just the square root of that last number you took. Or do you also realize it's the number that you divide by 2? So it's like 5 over 2. So when we factor this then, it factors to x plus 5 over 2, that quantity squared. So the bottom one, we'll do that one together. I'm going to take my negative 7, divide it by 2 and square it. Negative 7 squared is 49. 2 squared is 4. Hey, is the denominator always 4? Yeah, because you're squaring 2. Let's factor it now. X minus square root of 49 is 7. Square root of 4 is 2. There we go. You try the top right one. Tell me how you do. Did you take negative 11 over 2 and square it? And get 121 over 4? And then we're going to write it as a perfect square trinomial as x minus 11 over 2, and that quantity squared. How about our last one? Can you do this one by yourself? Oh, did you remember that there's a 1 in front of that? So I'm taking 1, dividing it by 2, and squaring it. And that's going to give me 1/4. So I get a plus 1/4 here. When I factor it, it factors to the square of x plus 1/2. So how you doing with that completing the square? Right, as of right now, where you should be able to do is to take any binomial, like an x squared plus 5x or x squared minus 7x, any of those, and write it as a perfect square trinomial, and then factor it to a squared binomial. Alrighty, we're going to continue on a little bit. So if we write this as a squared binomial, we take the square root of 9. We get the square of x minus 3. Here's why we did all that stuff. Because if I know that x squared minus 6x plus 9 can be written as the square of x minus 3, now I can solve this equation. So I solve it by taking the square root of both sides. I get x minus 3 equals plus or minus 5. Remember the plus or minus? Let's take the 3 and move it to the other side. So x equals 3 plus or minus 5. If we add those up and put them in a solution set, 3 plus 5 is 8. 3 minus 5 is negative 2. So that's why we complete the square. We do that because we want to be able to solve these equations with square roots. Let's keep going. So we love solving by square roots. So how do we solve this equation here? Well, you know what? That big red arrow over there is probably telling me to do something. Let's see what it's telling me to do. It's telling me to turn the left side into a perfect square trinomial. Sorry about my red box not looking as boxy as it should. So we turn the left side into a perfect square trinomial. So what that means is x squared plus 4x, I need to put a number there. And check this out too. I need to put a number over here too, because if I add something to one side of an equation, I got to add it to the other. So let's complete the square over here. If I do 4 divided by 2 and square it, that new c value is a positive 4. 32, I got to put a positive 4 over here also. Now let's factor. When we factor it, we know it's a perfect square trinomial. It becomes the square of x plus 2. 32 plus 4 is 36. Now take the square root of both sides. Bing, bang, boom. So I get x plus 2 equals plus or minus 6. Let's subtract 2 from both sides. And let's figure out what our answers are going to be now. We have negative 2 plus or minus 6. So that squiggly bracket set, negative 2 plus 6 is 4. Negative 2 minus 6 is negative 8. Not too bad. So that's a really neat tool to have, is that we can create a perfect square trinomial on the left side to solve it by square roots. We love solving by square roots. Okay, let's see if we can do the same thing here. I got to put a number in that blank space. I got a blank space, baby, and I'll write your name. So let's see, if I do 2 divided by 2 and square it, I'm going to get 1. So I put a plus 1, I put a plus 1. Let's factor. The square of x plus 1 equals 36. Square root both sides. I get x plus 1 equals plus or minus 6. Subtract 1. Negative 1 plus or minus 6. Let's separate them a little bit. Negative 1 plus 6 is 5. Negative 1 minus 6 is negative 7. Love it. Love it. Keep rocking. Here we go. So if we do the same thing, we have x squared minus 6x. We got to put a number here. 18, put a number there. Let's complete the square. Negative 6 over 2. Square it. We get 9. So put a plus 9 in the box. Put a plus 9 in the box. Great. Well, it's not a box. It's a line. Put it on the line. Let's factor that. The square of x minus 3 equals 27. I love solving by square roots. It's 2 steps. It's a square root and a move a number. x minus 3 equals plus or minus radical 27. Okay, let's play with radical 27 for a second. Let's go over here. Square root of 27, we simplify it. I'm thinking that 9 times 3 is 27. So I get 3 radical 3 for that value. So x minus 3 equals plus or minus 3 radical 3. I move my 3 over. Now, be careful here. I know you want to add the 3 and the 3's and get 6's or 9's or whatever. Don't do that. Our answer is just 3 plus or minus 3 radical 3. Let's leave it like that. That answers all we need. All right, your turn to try one. Oh, no! There's a 3 over there already. Well, let's get rid of the 3. Subtract the 3 away. So now I get x squared plus 10x equals 2. And let's put a number in the line. I got a blank space, baby. And I'll write your name. You didn't know Taylor Swift was co-teaching with me, did you? So let's see. 10 divided by 2 is 5. Squared is 25. So let's put a plus 25 in the box. See, Taylor Swift is distracting me. It's not even a box. It's a line. So now we factor. I guess we're getting pretty good at this. The square of x plus 5 equals 27. Oh, another 27. We just simplified that radical, didn't we? Let's remember to do that. So now when I take some red square roots, I'm going to get x plus 5. And let's cheat a little bit and remember that that's going to be 3 radical 3 from the last one. Subtract 5 over. So negative 5 plus or minus 3 radical 3. We are good. We are good. All right, one more to try. Here we go. I got that 15 there. Let's get rid of it. Add 15 to both sides. I got to make a perfect square trinomial. X squared, not minus 6, minus 12. Let's put a space there. I'm not going to do Taylor Swift, don't worry. Put a space over there. Let's see, how about completing that square? Negative 12 over 2 squared is 36. So let's put a plus 36 in there, a plus 36 here. Good, it's not a 27 anymore. I'm sick of simplifying radical 27. So I get the square of x minus 6. 18 plus 36 is 54. Love this. Square root and then move it. Take the square root of both sides. I get x minus 6 equals plus or minus. Ooh, let's simplify radical 54. If you go with your calculator, I think radical 54 is the square root of 9 and the square root of 6. And that's going to give me 3 rad 6. We like to move it, move it. So take that negative 6 and add it to the other side. And get x equals 6 plus or minus 3 radical 6. Love that answer. Boy, the algebra you can do. All right, so now we're ready for some really good ones. So in this one, we notice that we have an odd number in there as well. So first get rid of that 2. Let's add the 2 to the other side like we did before. X squared plus 7x. There's my blank space, baby. I'll write your name. No more Taylor Swift, I know. So now let's see what we can do here. We're going to take our 7. We're going to divide it by 2. We're going to square it. That's going to give me 49 over 4. I know what you're saying. I know what you're saying. Oh my goodness, I got to add 12 and 49 over 4. Remember, you have a calculator. Oh yeah, okay. So now we do some factoring. Remember, when we take the square root of that fraction at the end, it's just the square root of the top divided by the square root of the bottom. Or did you recognize it's half the b value? Oh, that's great. So now, if you're a little bit thrown off about that 12 plus 49 over 4, remember that you can write 12 as a fraction. Make the denominator a 4. 4 times 12 is 48. So 48 over 4 is 12. If we now add that to 49 over 4, I think we get 97 over 4. Remember, don't add bottoms. Did your calculator give you that same answer? I'm going to show you why you want to leave it as a fraction. Don't go saying, well, decimal. No, you don't want a decimal. Trust me. So I get 97 over 4. Stop whining. We don't want a decimal. I'll show you why now. Let's take some square roots. Fraction. Relax. Check out what happens. I know I get x plus 7 over 2 on this side. I get a plus or a minus. Can you take the square root of 97? The answer is, yeah, you could. You get an ugly decimal. So let's leave it as the square root of 97. Let's make a good 97 for you. Can you take the square root of 4? Yes, it's 2. Oh, that's kind of nice. So then when we subtract 7 over 2 from both sides, we get denominators that are like denominators. So we can add or combine our numerators together. Check out how I'm going to write this. You're going to love this. I know that it's going to be negative 7 over 2 plus or minus the square root of 97 over 2. But do you see how they both have the common denominator of 2? Let's combine the numerators. Now, you can't really combine them, I know. But what if we write it instead as x equals negative 7 plus or minus the square root of 97 all over 2? That is how the mathematicians write the answer. That looks cool. So check out what we did. Again, we made that perfect square trinomial after moving the 2. We took some square roots. It's okay, the square root of a fraction. You leave the numerator alone, the square root of the denominator works. And then we actually combine the numerator to get negative 7 plus or minus radical 97. Let's try one more and have a little bit of fun with this last one. Oh boy, we've never done one with a 2x squared term. You know how come? Because you can't. That's why. So watch what I'm going to do. I'm going to first subtract my 1, right? So that's going to give me 2x squared plus 6x equals 7. Now, we don't have this completing the square deal when the a value is greater than 1. So what are we going to do? Here's what we're going to do. If a is greater than 1, we're going to divide it out. Check it out. I'm going to divide everything by 2. So now what I get is x squared plus 3x. There's my blank space, baby. I told you I wasn't going to say that. I'm sorry. 7 over 2 and another blank space, baby. And I'll write your name. See, you didn't know I was co-teaching with Taylor Swift. Well, I'm not really co-teaching with Taylor Swift. But she was really good at this when she was in school. So let's complete the square. Let's take that 3, divide it by 2, and square it. And that's going to give us 9 over 4. So we're going to add 9 over 4 to both sides. I forgot my addition sign there. So the left side's not too bad. We get x plus 3 over 2, that quantity squared. Now, I know what you're saying. We got to add fractions. You got your calculator handy? If not, let's make 7 over 2 equal to 14 over 4. Multiply top and bottom by 2. And then when we add it to 9 over 4, 14 plus 9 is 23 over 4. We'll leave it like that. Again, don't go decimaling on me. Leave it as a fraction. You're going to like it. Now let's take that square root. Take the square root of both sides. I get x plus 3 over 2. I get a plus or a minus. Again, I can only take the square root of the denominator, so I'm going to leave the numerator as radical 23. Square root of 4 is 2. I love this. Let's move the 3 halves over to the other side. Can we combine our terms together and say that's negative 3 plus or minus the square root of 23 all over 2? Oh, if you leave it like that, I'll be your hero, baby. Oh, there's too many people here singing with me. So that's completing the square and solving equations with completing the square. It's a really good skill to have. It really helps us to solve these quadratic equations. So thanks for playing. I'm going to go cut a record now with Taylor Swift.